A few moments later. All right, check it out. We ended up doing quite a bit of work. We got our bracket all lightweighted, and we went ahead and put all the parts together as an assembly to see how they would fit and how it would look. So here's that main bracket. Actually, let's take a look at that. I'm gonna go open that real quick. So this is what we're working on, and we've got some good news on this. We did a few changes for weight and for function. So you'll note we got all these lightweighting holes here. We threw some lightweighting holes going around the pump. And you'll note that these two holes are bigger than that one. Now this is supposed to be bigger because that's the main bolt that the alternator pivots on. But what we did was we opened these two holes up so that this one will fit relatively tight, and then this whole assembly will pivot from this circle. So this is going to allow us to tension the belt. I don't have like an animation to show that, but you can imagine if you put a bolt here and here, the bolt's going to be loose around these holes, whereas this one, the bolt's going to be tight, and that would allow you to take the bottom of this and kind of swing this and pivot it about that bolt. Not much, because eventually you're going to run the bolt into this, but that little bit should be enough to tension our belt, because it's a tooth belt, not a serpentine belt. So that's our tensioning mechanism, or that's what allows us to tension it. We'll have to manually apply the tension and then tighten the bolts to hold it down. You'll see all the lightweighting holes we did. We also put a bigger radius on these and generally just messed with the design, trying to get it to look better. And let me show you the final numbers. So when we started with this, let me find my notes, we were at 29.1 ounces. That's where we were at. We are now at 17, basically 17 ounces. So we knocked quite a bit of weight off of that, 30–40% easy. Almost cut it in half. So this now weighs just barely over a pound, whereas this weighed, it was 3 ounces short of 2 pounds when we started. So it's much lighter. That's awesome. Price wise, I want to say this is going to cost about 330 bucks for the material, the machining, and the shipping cost. So not cheap, but it's okay. I'm just noticing this wall thickness is a little thinner than I would like. I may go back and bump that up a bit, but it's okay. It'll work like that. So anyway, that's about 330 bucks, but overall not bad. Now you can see in our assembly here, I did get some advice to go back and modify this to make it more rigid, so we're going to go back and take a look at that and probably do a revision on that. But for now, it'll physically put the parts in the same place, so I left it. And I modeled up a belt, and this belt, I wrote it down, but it's like 400 and something, 482 millimeters. So we'll probably order a belt in the 480 range, and then we'll basically pivot this to loosen it so that you can put the belt on at 480. And then when you swing it, it'll swing out to about 485. So that should give us enough room to install the belt and be able to tension it, which that's what we need. One cool thing you'll note is, well, one thing you'll note, I guess I'd say, we changed these to all socket head cap screws. We were going to use some flange head ones with the 12 point, but the lengths I needed, they didn't have, and I didn't want to go the custom bolt route or modifying bolt route. I wanted to just buy stuff. And I was going to use them here, and what I noticed is I'm threading this into aluminum, and the threads are only going to engage. If I use those other bolts with the 12 point, they would have only had just over a 1/4 inch of engagement into aluminum. So safe to say you're not going to be able to torque those very high, and there's no chance of stripping that because you're not torquing it high. Whereas if I buy these bolts, I could get 3/8 of an inch thread engagement. So 1/4 to 3/8, that's 50% more threads. So it was worth it. Also, these are probably not going to strip anyway because the torque spec will be pretty low. So anyway, we spec those. We went ahead and spec these as well. Part of designing a part is that I can buy bolts that'll work. And as you can see, these bolts are really long, but these are just straight off McMaster car. Like you can see these lighting up. So these are off the shelf bolts. I can just purchase them and they'll work. Looks like the threads might be a touch short. Might go, they sell these in 10mm increments. I added washers under these earlier, which changed it a bit. So we may go with the next size up. I think these are 220mm, or no, 100 and whatever, doesn't matter. Whatever they are. I think they're 120s, but they sell 130s, so I can get bigger if I need them. But I wanted to make sure I can get bolts that'll work. And these would work, and I can probably get longer ones if needed in 10mm increment, which is no big deal. I gotta go double check the belt. I'm pretty sure I can get the belt in 5mm increments, but I gotta go check. But overall, this is looking good. I don't see any issues. And overall, I'm liking how it looks. That was, I wanted to see this, and this makes me feel good that this is actually going to work. So basically, I think the next steps are to go double check our bolt lengths and make sure we can get this belt in the length that we'll need. And then we need to do a revision on this bracket. And we'll basically just be finalizing all of our parts and get a bill of materials for bolts and whatnot and get ready to place our orders. So anyway, hope y'all enjoyed this, and until next time, y'all take it easy.